All right, I want you to enter these notes. This is Module 3, Topic 3. We're not going to put a subsection for this. Just call this standard form for quadratics. All right, so first off, standard form is f of x equals ax squared plus bx plus c. That is function notation. We can also have an equation notation, y equals ax squared plus bx plus c. So first thing I want you to do is determine your ABCs, right? So a is the coefficient of the x squared. So it's the number that's in front of the x squared. So here's my example. Our a value is going to be -3. So I'm going to say a equals -3. All right, plus bx. So b is the coefficient of the x to the first degree. So in this case, our b equals 2. And then our c value is the constant. It's just the number, right? So in this case, our c value is 1. All right. So we know that if, let me turn myself off here. We know that if the parabola opens down from yesterday's lesson, that the a value is less than 0. So our a value would be a negative number. If the parabola opens up, then the a value is a positive number. So when it opens down, we know there's been a reflection over the x-axis, right? So if the a value is a negative number, the parabola reflects over the x-axis. Now the a value also tells us if there is a vertical dilation with the graph. So here's a great example here. We got y equals x squared. That's our parent function. Then we have y equals 4x squared. Well, that's the a value is 4, creates a vertical stretch. And then the red one is definitely compressed. It's wider or fatter than the parent graph. That's y equals 1/4 x squared. So what we say is if the absolute value of a is greater than 1, meaning it's 1.5, 2, 3, 4, 5, could be -1.6, could be -10. That's still great. The absolute value is greater than 1. Those are all examples of a vertical stretch, a vertical dilation. That's a stretch. If the absolute value of a is between 0 and 1, so 1/4 could be -1/4, could be -2/3, or it could be +2/3. Those are all vertical compressions that make the parabola wider or fatter. Okay, so very similar to what we were doing with absolute value functions. The same idea, except we're dealing with a parabola now instead of a v. Now, one thing that's great about standard form is the c value. The c value is going to be our y-intercept. So for example, the function y equals 6x squared plus 3x plus 5, that's going to have a y-intercept at 0, 5. So you see it right here in the equation. There's your c value. That will always be the y-intercept when the quadratic equation is in standard form. Please note, yesterday's form, vertex form, the number that we had, that is not going to tell you the y-intercept. No, 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 no. Only for standard form, this number, the c value, is the y-intercept. The reason why that always will work, if you think about it, the y-intercept is the y-axis, the number that's on the y-axis. The value of x is always 0 on the y-axis. So we would substitute 0 for x here and here, right? So 6 times 0 squared, well, that's 0. Plus 3 times 0, well, that's 0. So we'd have 0 plus 0 plus 5, so we get y equals 5 every time. So that's the key. So for standard form, the c value tells us the y-intercept for the parabola each and every time. All right, now the b value is not going to tell us anything right away. When we just look at the equation, we're not going to be able to know anything specific by just looking at the equation. So for today's lesson, what I want you to know is that the b value will work with the a value, and we're going to have a method for actually determining where the axis of symmetry is using a combination of b and a. I'm not going to show you that today. We're not going to talk about that today. For today, all I want you to know is this. If the b value is 0, then the y-axis will also be the axis of symmetry for that parabola. So an example of that would be something like y equals x squared minus 7. You notice how there's no x to the first degree? Well, that's because the b value is 0. 0 times x to the first degree would always be 0. So we don't have to show that in our equation. So if you ever see just y equals x squared plus 11, or y equals x squared minus 6, or y equals 5x squared plus 18, what you know about that parabola is the axis of symmetry is on the y-axis. Therefore, the vertex is also somewhere on the y-axis. Okay. When we have a b value, something like y equals x squared minus 4x plus 9, well, then the axis of symmetry will not be on the y-axis. It will not be on the y-axis. It will be somewhere else. Again, today's lesson, we're not going to talk about how we determine where that is. We will be looking at that down the line. Okay. So today, all I want you to know, if the b value is 0, then you know that the axis of symmetry is on the y-axis. Otherwise, we're not going to get anything from the b value today. We're going to be focused on the a value and the c value.